Contraction of skeletal muscle tissue occurs when actin and myosin myofilaments slide past one another, causing the sarcomere to shorten. It is important to note that the individual myofilaments do not change length themselves, but instead overlap each other to shorten the sarcomere. Moving in for a closer look, we can see the details of how this occurs. The molecules you see here are myosin, which at rest has both adenine diphosphate and phosphate molecules attached at the individual myosin heads, actin, tropomyosin, and troponin. When we decide to move, calcium is released from the sarcoplasmic reticulum. These molecules bind with the troponin molecules. This causes the tropomyosin molecules to move, revealing myosin attachment sites on the actin myofilaments. The single phosphate attached to the myosin heads gets released as the heads move to connect with the attachment sites on the actin. The resulting formation is called a cross bridge. The remaining adenine diphosphate molecule is then expended in what is called a power stroke, when the myosin heads pull the actin inward. Once the adenine diphosphate attachment is spent, adenine triphosphate molecules attach themselves to the myosin heads. These molecules trigger the release of the myosin heads from the actin attachment sites and are immediately broken down into adenine diphosphate and a single phosphate as the heads move back into their resting position. This is called the recovery stroke. If calcium is still present, the cycle will repeat again, and the sarcomere will continue to shorten until the calcium ions are transported back into the sarcoplasmic reticulum and the muscle relaxes.